Hello guys, so in this video tutorial I'm going to find how to calculate the reaction force on a simply supported beam. So as you can see in this picture, this is the simply supported I-beam. Yeah, this is the cross section, and you can, if you want to check the dimension, you can go to online, and this is the specification of this beam, so you can check it out on your own. Yeah, so we got two supports here at point A and point B. Yeah, and A to C there is a UDL, it's a 9 kilonewton per meter. Yeah, and at point D we got moment. So in this example I'm going to take this moment as a positive. So let's find the reaction forces in SOLIDWORks simulation. So as you can see here, I already performed the simulation, but I'm going to cancel this one and trying to explain from the beginning. As you see, this is the my I-beam section, and I already have created. I just create the in Sketch, as you can see here. Yeah, which is a 2 meter, 2 meter, and 2 meter. Yeah, so let's get started with this study. So I will just give name here. You can give is up to you or which kind of name you want to give it here, but I will give the 1001 as my standard name for this profile and for this study. Just click OK. Okay, so first of all we're gonna try to apply the supports. Yeah, so I'm going to fix geometry. So I'm going to apply at the point B immovable, so it means that no translation. Yeah, so I will click on this one. Yeah, actually it's a smaller one, so for the support we can use the symbol settings and make it around 200 for more visibility. Yeah, and click OK. So as you see in this picture, at point A we got a roller support, so let's apply the roller support here. So right click again in the fixtures, go to fix geometry, and here we will apply use reference geometry. Yeah, so in this one I will apply for this joint. Yeah, and please guys remember, when I'm using reference as a front plane, so this is my front plane which I haven't selected as my reference point. Yeah, that when front plane is used as a reference plane, that means x direction is direction 1 and y direction is direction 2. Yeah, so under translation, click to fix direction 2, that means a y direction and the normal direction in a z direction. Yeah, which I'm going to fix it so it can move in x direction. So this is along plane direction 2 and this one to normal direction. Yeah, so so far the structure is supported so that it cannot translate in all three directions, and it cannot rotate in y and z direction either. However, it can rotate in x direction. On the rotation, click to fix direction 1, means I'm talking about along plane direction 1. Yeah, as simple as that. Just click OK. We defined already our support in a beam. Yeah, now okay, I forgot to make it bigger, so go to edit definition and you can make here the symbol setting again 200. We are using 200 for the all supports, so we got two supports, so I'm using 200 for the more visibility. So it's a perfectly visible now. As you can see here, this is our point B and this is a point A. Yeah, now it's time to apply the external loads. So right click on this, go to the force. Yeah, first we will apply from A to C, which is a UDL 9 kilonewton per meter. Yeah, so I will select the entire beam, this one which is A and to C. Yeah, again I will use reference as my front plane. Yeah, and it will be per unit length. don't forget to click mark on this one. It's very important. Yeah, if you will not do it, then it will convert it into the Newton automatically. Yeah, but we need kilonewton per meter, so it will be per unit length. Yeah, and I will go for the normal to plane, and it will be 9,000 Newton per meter. Yeah, okay, so, no, sorry, it will be here, and it's a downward Y, so I will change here to reverse direction, and I will give again here 9,000 Newton per meter. Yeah, definitely it's a 9 kilonewton per meter, so it's 9,000 Newton per meter. Yeah, sounds good. So click OK. Okay, now it's time to apply a moment at point D. So let's try to apply this external moment. Yeah, so again external load, click to the force. Yeah, and here I'm gonna use joint. So this is our D point, I have already selected. Yeah, and reference point I will take again the front plane. Yeah, and this time I'm gonna use it normal to plane moment. Yeah, and this moment I'm taking as a positive. Yeah, so it will be how much it is, 30, so 30,000 Newton per meter. Yes, so there's a correct way to define. We already defined all the loading condition and also the supports. It's time to run this model. Yeah, so I will click here to run this study. Let's see. Okay, so right now I'm gonna skip this stresses here, displacement, and I'm not gonna cover in this tutorial the shear force diagram and bending moment diagram. Definitely I will cover in the next video, and I will explain you there what is the maximum stress occurred in this beam, also the maximum shear force and maximum bending, and on extra we will recover also the factor of safety distribution on this beam. So stay tuned for the next video. So let's just go for reaction forces. So if you want to find the reaction force at point A and point B, go to results, right click here and go to list result force, and here you can see the reaction force. Yeah, so I will just select the joint, so I will gonna select first as a yeah, and update. So as you can see here, yeah, in a Y direction, so are we getting something like this? Yeah, so here are we getting on a Y direction 20 kilonewton. Yeah, 20 kilonewton at point A. Fine. Okay, now let's check on a point B how much we are getting the value. So select the point B and update the result. So we are getting 2 kilonewton here. Yeah, as simple. It's so very easy to find the reaction forces in a SOLIDWORks simulation. It's the best way to find it out. So we can write it down here that point A reaction force was 20 kilonewton and here was 2 kilonewton. Yeah, I'm not gonna write the unit because it's for sure that we are talking about kilonewton right now. Yeah, so 20 kilonewton at A and 2 kilonewton at B. So that's all for now, and in next tutorial, as I mentioned earlier, that I'm gonna cover shear force diagram and bending moment diagram. Yeah, so stay tuned for the next video. Thank you so much for watching my video.